Okay, in this problem, I have a 75 kilogram skier, starts down a 50-meter high, 10-degree slope on frictionless skis. What is her speed at the bottom? Okay, so notice here that this says frictionless, so that's good to remember. And let's write down our givens and finds. So we're given that we have a 75 kilogram skier. She starts, let's say x is equal to 50 meters. And theta is equal to 10 degrees. I'm going to say mu k, the coefficient of kinetic friction, is equal to 0. And I want to find her speed at the bottom. So I'm going to say that's V final. Okay, so let's draw a picture. So we've got a picture, and we've got a skier. And we'll give her poles. She's pretty happy. She has hair. There we go. Okay, and this is my theta. And so what we're going to do is we need to, on this problem, we're going to have, I guess we'll do our boundary first. So if I do my boundary, it's around here. So she's going to have the force of gravity down, and she's going to have the normal force up. So that's going to be like this. So remember, the normal force is always perpendicular to the surface, force of the normal. And then she's also going to have, is she going to have, I would say she was going to have friction, but she isn't because she has frictionless skis. So all she has is those two forces based on the information here. So let's make a free body diagram. And I'm going to add in this incline. So I'm going to do this incline. And I'm going to do the free body diagram here. So I'm going to draw, this is her, and my force of the normal is perpendicular, like that. But my force of gravity is down like this. Because the force of gravity is always, that's not even that vertical, so let's see if I can erase that. A little more vertical. Like straight up and down, like that. Oops. FG. And let's extend this a little bit more. Okay, and I'm going to draw this. Now this is my theta. And what I'm going to do is I'm rotating my coordinate system. So I'm going to now say that x is down the hill, and this is y. So y is perpendicular to down the hill direction. Okay, so and what I know is that she starts here, and we're going to call this spot right here x. So let's say this is where she is. I'm going to say this is x equals 0. And at the bottom of the hill here, this is going to be my x final. Okay, and so what I need to do then is I need to break up my components. And so I'm talking about the x direction and the y direction. So I can see the y direction is the force of the normal, but my FG has both x and y components. So I'm just going to move this over here for just a sec. FG. And what I want to do is I want to find the x and y components of force of gravity. So this is going to be a right triangle right here. And so if you do the geometry, if this angle here is theta, and I were to drop this down here, this would be a right angle. So this must be 90 minus theta. And if that's true, then this is a right triangle here to here. Let's see. This is a right triangle here. So if that's true, then this angle up here must be theta. This is theta. Okay, so now we're going to break up our, we're going to create our Newton's second law from these with these new coordinates. So the sum of the forces in the x direction equal to, well, I can see that I'm going to have a net force in the x direction due to this piece of the force of gravity. So I know then that means that I'm going to have the sum of the forces equal to ma. And the only force I have in that direction is the force of gravity here. And this is opposite the angle, right? So that means I'm going to have sine. So I'm going to have the force of gravity, let's say the force of gravity in the x direction. So that's my FGX. This is going to be my FGY. But the forces in the x direction is equal to ma. And I'm looking for, in this example, the velocity, the final velocity. So I know I'm going to need to then to figure out a. So a is equal to Fg divide x direction divided by m. So I divide by m on both sides to get a alone. And I want to plug in for Fgx. So I'm going to have Fgx is Fg sine theta. And why sine? Well, because this part of Fg here, this part right here is opposite the angle. So when the side is opposite the angle, then I use sine. So I'll be using sine. So I'm going to Fg sine theta over m, and I know Fg is equal to mg sine theta over m. So I'm going to cancel my m's, and I just get a is equal to g sine theta. And if I plug in, I'm going to have a is equal to 9.8 meters per second squared times sine of 10 degrees. And that gives me 1.7 meters per second squared. And I also know, if I go back up here and look, I know that from x0 to x final, that's equal to 50 meters. So I know this distance is equal to 50 meters. And so I'm going to use the v final squared is equal to v initial squared plus 2a delta x, right? So what happens is my my skier starts right here at a speed of 0 and then heads down the hill and gains momentum and gains speed as she goes. So my initial velocity is going to equal 0. So I can cross this out. I know my a because I just solved for it, and I know my delta x is equal to 50. So v final is equal to the square root of 2a delta x. Plugging in, I get v final is equal to 2 times 1.7 meters per second squared times 50 meters square root. And when I solve, I get 13 meters per second.